convert repeating decimal to common fractions. So the fact is that we liken rational numbers to be any number that can be expressed as a common fraction, A over B. But we know repeating decimal, for instance, example 2.3 with a dot, which can be written as 2.33333 to be a repeating decimal. Now, how do we convert this to the form A over B to tell us that it's also a rational number? Because we agree that repeating decimals or recurring decimals, repeating decimals is also called recurring decimals. So you may see it somewhere to be recurring decimals. Now, repeating decimals is classified as rational numbers. So how do we ensure that we can express this repeating decimal as something over something, a numerator and a denominator? So to do that, first you say let x equals 2.3333 in that order, and make it as equation 1. Now, we want to ensure that the repeating decimal is found before the decimal point, and after the decimal point, it continues with the repeating decimal again. So looking at the equation 1 from the question, what is repeating is only found after the decimal point. So we're going to ensure that what is repeating moves before the decimal point, and it goes just like that after the decimal point again. And in doing that, there's a number we can multiply by this decimal so that the repeating decimal will move to before the decimal point, and after the decimal point it still remains. So to do this, what we do is that we say equation 1 with the equation 1, this equation 1 with the decimals, the value of the decimal point changes with the multiples of 10. So if we multiply this decimal point value with 10, it will move the decimal point to the next value, making the repeating decimal to come first. So it will become equation 1 times 10. So we get x times 10 will give us 10x, which is the same as this 2.333 times 10. It would have made the decimal point here to move to this point by 1. So it will become, instead of 2.3, it becomes 23.3333, and we name that one equation 2. So we realize that this condition is satisfied here because we can see that before the decimal point there's 3, and after the decimal point there's 3 again, which is the concept you should get. Now what we do next is, now because it has 2 equations, we have to solve them simultaneously to get the value of x. If you get the value of x, then it gives us what we want. So to do that, we say equation 2 minus equation 1. And from the equation 2, we have 10x here. 10x times minus the x is 9x, which is the same as, also saying this, 23.3333 minus 2.333. With the 0.333 and the 0.33 in the equation 1 and 2, they will subtract each other and they tend to 0, leaving 23 minus the 2 alone, which is what? 21. 23 minus 2 is 21. So we will resolve and get the value of x, which is dividing here by 9. This by 9, we'll get x equals to, now with 21 and 9, there's a number that is common to them. You realize that 3 is common to, you can divide 21 and at the same time divide 9. So 3 into this, we have gotten 7. 3 into 9, we get what? 3. So we get 7 over 3, which becomes our solution. For realizing that 7 over 3 is is written in the form A over B, which was a repeating decimal, confirms the fact that 7 over 3 is a rational number, which was originally a repeating decimal. Thank you.